We got question 16, which is polynomial long division. And usually, if there's a trick or a way to cheat, I'll show you that. In this case, I can't think of a good way to cheat on this one, so we're just going to have to man up and do it. Let me show you guys polynomial long division. It's the same exact steps as old school long division, which apparently everyone hated back then too. All right? So I'm going to make up a problem. How's about 751 divided by 3? Okay? 751 divided by 3. Do you guys remember this from back in like second grade? How do you divide 751 by 3? Well, how many times does 7 go into, or how many times does 3 go into 7 without going over? 2.
2.
Okay. 2, and then I multiply it by here and make it 6, right? Right? 2 times 3 is 6. And then I subtract it. So I like to think of subtracting as adding negative. You'll understand why I'm doing that in just a second. But I like to think of it as adding negative. That makes me feel comfortable. And then when I add negative 6, 7 plus negative 6 is 1. I drop down to 5. And then I ask myself, how many times can 3 go into 15? And the answer is 5 times. So then I make this a 15. Cool. I add negative 15. That becomes 0. I drop down to 1. How many times can 3 go into 1? None times. So I have a remainder of 1 left over that didn't end up being a perfect 0. So my answer is 250 remainder 1. Or 250 1/3. Because you take your remainder and divide it by your original divisor. Right? So, anyway, you guys remember this? We cool? All right. Now, I'm going to do the problem. Just so I gave you a warm-up on long division. Let's go with polynomial long division. It's the same exact steps. 3x4 plus 2x cubed plus 4x. There's a few things I want to do before I start off this problem. The first thing I'm going to do is add in placeholders. What I mean by placeholders is this. I put in a 0x squared and a 0. That didn't change anything in there, did it? Because if I add 0x squared, it's really just adding 0. I didn't change nothing.
Yeah.
But what it did was it kind of gave me an x4, x3, x2, x1, x0. It kind of gave me a placeholder. It saves space for those things. That's an important step that you need to do. Okay? All right, now let's do the long division. How many times, what do I have to multiply x by to make it into 3x to the 4th power? Or just do this. What is 3x to the 4th power divided by x? It's the same as 3x to the 4 minus 1, right? 3x cubed. Or this x cancels out with one of these, so there's only 3 left. So it's 3x cubed. We cool? All right. I'm going to multiply 3x cubed by everything in here. So this becomes 3x to the 4th power plus 15x cubed. Did I lose you? Sure?
Yeah.
Okay, good. Now I'm going to subtract it, but I don't like subtracting. I like adding negative, and the reason why I like adding negative is because I always try to distribute my negatives. So I like going like this. The reason why I say I like adding negatives is because when I just straight up subtract this thing, students always forget that the negative can go, or needs to go both here and here. Because you're subtracting all of this.
Mm-hmm.
So I like to remember to just multiply through by -1 and then add them. It's the same thing as subtracting. So now you know my crazy antics. All right, this gets killed by that. I'm happy about that. And then 2x cubed minus 15x cubed is -13x cubed. Cool. What do you have to multiply x by to make it -13x cubed?
No.
Yeah, you're right. -13x squared. Because if you multiply an extra x on there, you have -13x cubed.
Yeah.
Cool? Okay. When I multiply this thing through, I end up getting -13x cubed minus, oh shoot, what is 5 times 13? 65. 65x squared. Right? Bradley, check if I'm wrong. When I subtract this thing over here, I'm going to multiply through by -1 and then add it. Are we cool with that? Okay. This is why I added the placeholders. Because if I didn't have the placeholder and I just had a 4x, I'd be trying to add 4x plus 65x squared. You can't add those. They're two separate beasts.
Mm-hmm.
But since I added the placeholder, I can just say, okay, well, that's 0x squared. And now I can add, well, this plus that kills itself. I like that. And then this plus that's just 65x squared. Are we cool? And then you just keep playing this game. Let's keep on going because it's annoying. How many times can x go into 65? 65x times. And shoot, 65x squared. Bradley, what's 65 times 5? You can do it too, Adam. 325? All right. And then I'm going to subtract these. So I'm going to negative. I'll drop down to 4x. This gets killed with that. I like that. Then over here, I end up getting negative 321x. Oh, this is a horrible problem. All right, I'm almost done. How many times can x go into 321x? Negative 321 times. So I multiply this by here, and I'm getting negative 321x plus, minus. What is 5 times 321?
5.
Huh? What is 5 times 321?
1605.
1605, okay. It's minus 1605. Then I drop down to 0. This cancels, oh wait, I gotta have to add those. That cancels out with that, and I'm left with 1605. How many times does x go into 1605? What do I have to multiply x by to make it into 1605? Lucas and Bradley are saying 1605. You said 1605 too. You guys are all
I
wrong.
didn't say anything.
Oh, okay, you didn't say anything.
There
Well,
is no x.
there's no x over here, so I can't multiply x by anything to turn it into that. Right? So we're done. This is our remainder. Or more accurately, our remainder is 1605 divided by x plus 5. Is there a trick on how to do this? None that I can think of. I'm sorry to say.
So you just leave it like
Well, no, I mean, that's the answer. It's C.
Oh, okay.
16 over 5 over x plus 5.
So, okay.
But I'm saying, like, is there a trick? Could I have used the answers to get my answer? You know what I mean?
Mm-hmm.
No. No.
So you just have to.
You just got to do it. You got to know how to do long division. I wouldn't say, though, that long division, I mean, if you don't know how to do long division, you're going to this test, or maybe you're freaking out right now because this looks horrible. It's not really that horrible, but it looks horrible.
Mm-hmm.
And say you don't do that, I'm guessing that you're going to only miss 1 or 2 problems. So it's not like that huge of a deal, and I don't want to say like certain things in math are a bigger deal than others, but this thing is not really going to kill you if you don't remember it, but you should know how to do it. Cool? Now, is learning polynomial long division useful later on in math? I can tell you right now that if you're ever going to take a class called partial differential equations, yes it is. However, if you're going into communications, I'm betting you're not going to get into partial differential equations. So maybe this is where you stop having to learn this thing. Polynomial long division. I'm just being honest with you. Cool?
Mm-hmm.
All right. So those are 2 I definitely wanted to